You did not burn your pan. I know what you think happened. You left it on the burner too long, you walked away, you came back to a smoking disaster, and now the bottom is covered in a layer of black that no amount of scrubbing, soaking, or cursing has been able to remove. You tried dish soap. You tried steel wool. You tried soaking it overnight in hot water. You stood at the sink for 20 minutes with a green scouring pad and elbow grease, and the black layer barely flinched. And at some point, you looked at the pan and thought, "This is ruined. I need a new one." You do not need a new one. The pan is not ruined. The metal underneath that black layer is identical to the day you bought it. What you are looking at is not damage. It is polymerized oil. And polymerized oil is not burnt food. It is not carbon. It is not a permanent scar on the metal. It is a layer of fat molecules that have been chemically transformed by heat into a cross-linked polymer film that is bonded to the surface at the molecular level. It is, in the most literal sense, a thin sheet of plastic that your stove manufactured on the bottom of your pan while you were not looking. And the reason you cannot scrub it off is not because it is burnt too deeply. It is because you are fighting a polymer bond with a physical tool. A scouring pad attacks a surface mechanically. It scratches, it abrades. But a cross-linked polymer is chemically bonded to the chromium oxide layer of your stainless steel. The only way to break a chemical bond is with chemistry, and the chemistry costs $2. 2 ingredients that are sitting in your bathroom cabinet right now. One breaks the polymer chain. The other lifts the fragments off the metal. Together they dissolve 10 years of burnt-on damage in 5 minutes, without you scrubbing a single stroke. The ingredients are hydrogen peroxide and baking soda. And the cookware industry, which sells $30 billion worth of pots and pans globally every year and depends on you believing that a burnt pan is a dead pan, has absolutely no interest in you ever learning that a $2 paste can bring the worst pan in your kitchen back from the dead. Welcome to Camping Secrets. If these stories matter to you, the subscribe button and the bell are the best way to make sure this knowledge survives. This is where we dig up what the industry buried. Now let me take you inside the black layer, because what is actually happening on the surface of a burnt pan is one of the most fascinating chemical transformations in kitchen science, and understanding it is the key to reversing it. When you heat cooking oil past its smoke point, the triglyceride molecules that make up the oil begin to break apart. Triglycerides are 3 fatty acid chains bonded to a glycerol backbone. At temperatures above the smoke point, typically 350 to 450 degrees Fahrenheit for most cooking oils, the fatty acid chains detach from the glycerol. The glycerol decomposes into acrolein, which is the acrid chemical that makes your eyes water when oil smokes. And the freed fatty acid chains undergo a process called polymerization. Polymerization is what happens when small molecules link together into long repeating chains. It is the same fundamental process that creates nylon, polyethylene, and every other plastic material on Earth. When fatty acid chains polymerize on a hot metal surface, they form a cross-linked network of hydrocarbon molecules that is chemically bonded to the metal oxide layer beneath it. This network is hard, glossy, and virtually impervious to water, soap, and mechanical abrasion. This is the exact same process that creates seasoning on a cast iron skillet. When you season cast iron, you are intentionally polymerizing oil on the surface to create a nonstick layer. The only difference between the prized seasoning on a cast iron pan and the hated burnt residue on a stainless steel pan is that one was intentional and the other was an accident. The chemistry is identical. And here is the detail that changes everything about how you approach the problem. If the black layer is a polymer, a form of plastic, then it can be broken down the same way any polymer can be broken down. Not by scrubbing, not by brute mechanical force, by chemical attack on the polymer bonds themselves. This is where hydrogen peroxide enters the equation. And what it does to polymerized oil is extraordinary. Hydrogen peroxide is a powerful oxidizer. Its chemical formula is H2O2, 2 hydrogen atoms and 2 oxygen atoms. The oxygen-oxygen bond at the center of the molecule is unstable. When H2O2 contacts organic material, that bond breaks and releases reactive oxygen species, nascent oxygen atoms that are among the most aggressive oxidizers in chemistry. These oxygen radicals attack the carbon-carbon and carbon-hydrogen bonds in the polymerized oil film, breaking the cross-linked polymer chains into shorter fragments. The plastic-like film that was impervious to scrubbing is chemically dismantled into smaller molecules that are no longer bonded to each other or to the metal surface. Baking soda, sodium bicarbonate, serves two functions simultaneously. First, it is a mild alkaline compound with a pH of approximately 8.3 in solution. Alkaline conditions accelerate the oxidative breakdown of polymerized fats. The combination of an oxidizer and a base creates a synergistic chemical environment that is dramatically more effective at breaking polymer bonds than either compound alone. Second, baking soda is a gentle physical abrasive. Its crystalline particles are soft enough to avoid scratching stainless steel, aluminum, or ceramic surfaces, but hard enough to lift the loosened polymer fragments off the metal once the chemical bonds have been broken. The hydrogen peroxide attacks the bonds. The baking soda lifts the debris. The combination works in 5 to 30 minutes on damage that years of scrubbing could not touch. Professional restaurant kitchens know this. Every commercial kitchen in America has a protocol for burnt pan recovery. And it is not steel wool and elbow grease, it is chemistry. Commercial kitchens use alkaline degreasers, which are industrial versions of the exact same baking soda and peroxide reaction. The branded products cost $15 to $30 per bottle. The raw ingredients cost $2. If you have made it this far, you already know more about polymerization chemistry and cookware surface science than 99% of home cooks, and a troubling percentage of the cookware salespeople who told you the pan was beyond saving and sold you a replacement for $40 to $200. Subscribe and share this with someone who has a cabinet full of blackened pans they have given up on. Now stay with me, because the economics of the cookware replacement cycle are where this story gets infuriating. The global cookware market generates over $30 billion annually. In the United States alone, consumers spend over $7 billion per year on pots, pans, baking sheets, and cookware sets. The average American household replaces cookware every 3 to 5 years. The number one reason cited for replacement is cosmetic degradation, meaning the pans look bad, not warped, not structurally failed. They look burnt, stained, and discolored. Functionally, the pan is identical to the day it was purchased. The metal has not thinned. The heat distribution has not changed. The handle is not loose. But the bottom is black and the outside is brown, and the homeowner is embarrassed to use it when guests are over. A stainless steel skillet costs $30 to $80. A quality stainless set costs $150 to $500. A premium brand like Allclad or Le Creuset costs $200 to $800 per piece. These are objects built from materials that last decades. Stainless steel does not wear out. It does not degrade. The chromium oxide passive layer that gives stainless steel its corrosion resistance self-heals when scratched. A properly cared for stainless steel pan will outlive the person who bought it, but properly cared for does not mean never burnt. It means knowing how to reverse the cosmetic damage that cooking inevitably causes. And the cookware industry has a $30 billion reason to make sure you never learn that reversal costs $2. Now here is exactly how to do it. And this method works on stainless steel, aluminum, ceramic-coated, and glass bakeware. It is the same protocol used in professional kitchens adapted for home materials. Step 1. Allow the pan to cool completely. Never apply cleaning agents to a hot pan. Thermal shock from cold liquid on hot metal can warp thin pans, and the chemical reaction between peroxide and hot polymer produces excess fumes. Cool pan, room temperature, every time. Step 2. If the burnt layer includes visible food debris, chunks of carbonized material, or thick crusty deposits, perform a deglaze first. Place the pan on the stove with half an inch of water and a splash of white vinegar. Bring to a simmer for 3 to 5 minutes. Use a wooden spoon or silicone spatula to gently push the loosened debris. Pour off the water. This preliminary step removes the top layer of carbonized food and exposes the polymerized oil film underneath, which is the actual target of the chemical treatment. Step 3. Make the paste. In a small bowl, combine 1/4 cup of baking soda with 2 to 3 tablespoons of 3% hydrogen peroxide, the standard concentration sold at every pharmacy. Stir into a thick paste with the consistency of toothpaste. If the mixture is too runny, add more baking soda. If too thick, add a few more drops of peroxide. Step 4. Apply the paste generously to every burnt, discolored, or stained area of the pan. Cover the bottom, the sides, and the exterior bottom where grease splatter has baked on over months or years of stovetop use. The exterior bottom of a pan is often the worst area because grease that drips down the side polymerizes on the burner-facing surface during every subsequent cooking session. building layer upon layer of varnish that nobody ever thinks to clean. Step 5. Wait. This is the step that separates this method from every failed scrubbing attempt. The peroxide needs dwell time to break the polymer bonds. For light discoloration, 15 to 20 minutes is sufficient. For moderate burnt residue, 30 minutes to 1 hour. For severely blackened pans with years of accumulated polymerized grease, apply the paste. Cover with plastic wrap to prevent the peroxide from drying out, and wait 2 to 3 hours. The chemistry does the work while you do something else. No scrubbing, no standing at the sink. The molecules dismantle the polymer while you are in the other room. Step 6. After the dwell time, use a non-scratch scouring pad, a nylon brush, or even a folded paper towel to wipe the surface. The polymerized oil that was impervious to scrubbing before the treatment will now lift off with minimal effort. The fragments have been chemically detached from the metal surface by the oxidative breakdown. You are not scrubbing the burn off. You are wiping away the remains of a polymer that has already been destroyed. Step 7. For pans with extremely heavy buildup that does not fully dissolve in one treatment, repeat the process. Apply fresh paste. Wait another hour. Wipe again. Each cycle removes another layer of polymerized material. 3 cycles will strip a decade of accumulated burn damage from any stainless steel or aluminum pan. Step 8. For the final polish, sprinkle a thin layer of dry baking soda onto the clean, wet surface and buff with a soft cloth in circular motions. This removes any remaining haze and restores the original reflective luster of the metal. If you want the absolute mirror finish that the pan had when it was new, follow the baking soda polish with a thin application of Barkeeper's Friend, which contains oxalic acid, and buff to a shine. The oxalic acid chelates any remaining iron or mineral deposits and leaves the chromium oxide layer gleaming. Total material cost: approximately 10 cents of baking soda and 15 cents of hydrogen peroxide per pan treatment, under 25 cents. A bottle of hydrogen peroxide costs $1. A box of baking soda costs $1. Together they treat every pan, baking sheet, and piece of cookware in your kitchen multiple times over. Total investment $2. I need to be completely honest with you about limitations. This method works on stainless steel, aluminum, ceramic-coated exteriors, and glass bakeware. Do not use it on the interior of nonstick or Teflon-coated pans. Hydrogen peroxide and baking soda can damage or degrade the PTFE nonstick coating, causing it to peel or lose its release properties. For nonstick interiors, use only the boiling water deglaze method or a gentle soak in warm soapy water. If the nonstick coating is already peeling, scratched, or flaking, the pan should be discarded regardless of cleaning method because damaged PTFE can release harmful compounds during cooking. Do not use steel wool on stainless steel pans. Steel wool leaves microscopic iron particles embedded in the surface that cause rust spots within weeks. It also scratches through the chromium oxide passive layer, creating areas where discoloration and pitting can occur. Every professional kitchen uses non-scratch pads for exactly this reason. Hydrogen peroxide degrades in light and heat. Use it fresh from the bottle. Do not mix the paste hours in advance and store it. Mix immediately before application. Old peroxide that has been sitting in a warm cabinet for months may have degraded below effective concentration. If your peroxide does not fizz when applied to the baking soda, it is expired. Buy a fresh bottle. And one detail that will prevent your pans from ever reaching this state again. After every cooking session, while the pan is still warm but not hot, deglaze with a splash of water. The thermal contrast loosens food particles and oil residue before polymerization can occur. Wipe with a sponge and dish soap. Dry immediately. This 30-second habit after every meal prevents the gradual buildup of polymerized oil that accumulates over months and eventually creates the blackened pan you thought was ruined. The polymer chemistry of cooking oil has been understood since the 19th century. The oxidative power of hydrogen peroxide has been documented since Louis-Jacques Thénard discovered the compound in 1818. The alkaline cleaning properties of sodium bicarbonate have been used in household cleaning since Nicolas Leblanc isolated it in the 1790s. The combination of an oxidizer and a base to break down organic polymer films is standard protocol in industrial surface chemistry. Every restaurant kitchen in America knows this. Every professional cleaner knows this. Every commercial degreaser on the market is built on this principle, and the $2 version works identically to the $30 commercial version. because the active chemistry is the same two compounds mixed in the same proportions. A $30 billion cookware industry depends on you looking at a blackened pan and thinking replacement. A $40 to $200 receipt for a new piece of cookware depends on you never learning that the black layer is not damage. It is a polymer film. And polymer films dissolve in oxidizing alkaline conditions the same way they have dissolved since Thenard discovered hydrogen peroxide in a Paris laboratory 207 years ago. That black skillet in the back of your cabinet could look factory new by tonight. That baking sheet you have been hiding from guests could be spotless by the weekend. And that $200 cookware set you were about to throw away and replace could be restored for the cost of 2 ingredients that are already in your bathroom cabinet. The metal was never damaged. The food was never fused to the surface. The black layer was always just chemistry. And chemistry that goes on can always come off. If this vault changed how you see the burnt pans in your kitchen, subscribe and share this video right now. Every share puts this knowledge in front of someone who is about to spend $200 on new cookware because nobody told them that $2 worth of powder and liquid could undo a decade of damage in an afternoon. Every subscription keeps this channel digging deeper into the vaults they thought were sealed forever.